Good morning, students. Welcome to our basic science class. In our previous class, we have discussed about acids and alkalis, properties of acids and properties of alkalis. At the end of today's video, you will be able to describe neutralization process and different indicators used to identify acids and alkalis. Let's move to the topic. While traveling, maybe you have observed some traffic junctions. So you can see traffic lights. In traffic lights, how many colors we can see normally? Red, yellow and green, right? Red color is to stop. So when we see the red color, we will stop the vehicle. The same way, to identify acids and alkalis, we have different indicators. Each indicator will give us different color. In acid, it will give one color. In alkali, it is given another color. For example, in our last class, we have conducted an experiment by using universal indicator. We have identified some alkalis and acids. You have observed blue color and orange color in our last class. So now we are going to see some indicators. Indicators will help us to find acids and alkalis. First indicator we are going to check is phenolphthalein. Phenolphthalein. What will be the color of phenolphthalein in acid and alkali we are going to check. Phenolphthalein will be colorless in acid. It will be colorless in acid and pink color in alkali. So if you are adding phenolphthalein into an alkali, the color of the alkali solution will change into pink color. So that is indicator of phenolphthalein. Phenolphthalein gives pink color in alkali and colorless in acid. Next one we are going to check is methyl orange. Color of methyl orange in acid and in alkali. In acid medium, the color of methyl orange will be red color, reddish orange or red color in acid medium. If it is alkali medium, the red color will be if it is an alkali medium, the color will be yellow. So red and yellow colors will be there. So methyl orange gives red color in acid and yellow color in alkali. Now let's see a list of indicators which we can use to identify acids and alkalis. Here you have a big list of indicators. Look at the table. In this table you can see substances used, color in acid and color in alkali. And here blue litmus paper shows red in acid and blue in alkali. So when we are taking blue litmus paper and we are dipping in acid, the color of blue litmus paper changes to red. But if you are dipping the blue litmus paper in alkali, there is no color change. The blue litmus paper stays blue. So if you are dipping the blue litmus paper in water also, it stays blue. So only in acid the color of the blue litmus paper will change. So blue litmus paper we can use to identify acids only, not alkalis. In the same way, there are many things given in the table. Find out which one can be used to identify acid and which one can be used to identify alkali. If that substance can be used to identify acid, write acid near to it. If that substance, that indicator can be used to identify alkali, write alkali near to it by using pencil. That's a follow-up activity from today. Next, we are moving to our universal indicator. As you have seen in our last class, we have done some experiments by using universal indicator. So there are different colors, many colors shown in this universal indicator bottle. You can see that is pH scale. Universal indicator is also known as pH solution. So by using universal indicator, we can identify acids and alkalis. So there is a scale of colors and start from 1 and ends at 14. 1 to 14 range is the. So when we are using this universal indicator, if you are adding this universal indicator to a strong acid, the color of the solution will be red color. For example, sulfuric acid, hydrochloric acid, nitric acid, these acids are strong acids. If you are adding this acid into our lemon juice or the fruit items which we are getting in our home, that is acid contains in food items, those acids are weak acids. So the color of this indicator in the weak acid will be different. Slightly orange color will be there. So red means strong acid. Then if it is neutral, if you are adding this universal indicator in water, the color will be green in color. That is neutral. And if it is alkali, the color will slowly change into blue color. So I'll show you a small video about this experiment. Watch it.
Litmus is red in acids and blue in alkalis. Litmus paper is made from lichens, which have been used to dye cloth for hundreds of years. It can be used as a liquid or paper. The paper is easier and more reliable. It comes as red litmus paper and blue litmus paper. Red litmus paper changes colour from red to blue under alkaline conditions, but no change under acidic conditions. Blue litmus paper changes colour from blue to red under acidic conditions, but no change under alkaline conditions. So just remember that red litmus paper changes colour for alkalis and blue litmus paper changes colour for acids. However, litmus paper only tells us whether something is acid or alkali, but it does not tell us how acidic or alkaline a substance is. For this, we have the pH scale and a universal indicator. Universal indicator is a mixture of different indicators, or dyes, which has many different colour changes, and so shows us the pH value of the solution. Again, it can be used as a liquid or a paper. The pH runs from 0 to 14, with 0 being extremely acidic, 7 being neutral, and 14 being extremely alkaline. Stomach acid is a strong acid with pH of about 2. Acid rain has a pH of about 5.5. Milk is neutral with a pH of 7. Seawater is a slightly alkaline. Soapy water is a strong alkaline. And bleach is a really strong alkaline with a pH of 13. Universal indicator is so called due to its ability to indicate the entire pH spectrum. There are other indicators that can be used that have other colour changes, but these two are the ones you need to know.
So pH scale. pH scale starts from 1 and ends at 14. If it is 1, the color will be red. That means it is strong acid. And then slowly the color changes to green, then green to blue. That is 14. So if it is blue color, the number of pH scale, the number will be 14. Number 14 means it's a strong alkali. So like that, by using a pH solution or universal indicator, we can identify acids and alkalis. So now we have seen acids, alkalis, acidic substances and alkaline substances are there. Water, if you are taking water, water is not alkaline or acidic. Water is neutral. If you are adding acid into water, the water will change into acidic. If you are adding alkali into water, it will change into alkaline. Now we are going to check what will happen if you are mixing acid and alkalis. Acids plus alkali, what will happen? The reaction will be neutralization. That means if you are adding acid and alkali, we will get a neutral solution which is similar to water property. That means there won't be acidic property or alkaline property also. So we are going to see a neutralization reaction. When a substance is neutral means it is not acidic or alkaline. So let's see neutralization reaction. For this we need this arrangement. We need a conical flask. Conical flask is required, and burette, pipette, these things are required to conduct neutralization reaction. It is also known as titration reaction. Titration. So understand the apparatus shown in this neutralization reaction. There is burette, pipette, conical flask, stand. In burette we are taking hydrochloric acid, and in pipette we are taking caustic soda or sodium hydroxide, and we are pouring that into conical flask. And after pouring sodium hydroxide into conical flask, we will swirl it. We will shake it well. After that we will add 2 drops of phenolphthalein. So add 2 drops of phenolphthalein into the flask and stir well. Place the conical flask below the stopcock of the burette. You can see this is tap-like structure, that is stopcock. Open the stopcock slowly and add acid drop by drop into the conical flask while swirling it continuously. So you can observe there will be a color change, like you are adding phenolphthalein into alkali, the color will be pink in the conical flask. Then you are adding acid into the conical flask. So that acid will react with the alkali inside the conical flask and the pink color will change into color of phenolphthalein acid, that is colorless. So the pink color inside the conical flask will change into colorless. So when that pink color slightly changes to colorless, we can stop the reaction. That means that solution is neutral now. So in phenolphthalein, as you know, in alkali it is pink, in acid it is colorless. So when it is changing into colorless, we can stop the reaction. So in neutralization reaction, when we are mixing acid plus alkali, we are getting two substances. One is salt, other one is water. Salt is not just common salt in our kitchen. We will get common salt when hydrochloric acid and sodium hydroxide is reacting to be common salt of the product. So salt and water will be there are some many salts we can form like that. So neutralization means acids reacts with alkalis and changes into a neutral solution. And the products will be salt and water. Okay. Now let's see some uses of acids and alkalis. Acids and their uses. Vinegar. As we all know, we are using vinegar or surka for pickles and other substances. Citric acid, food preservation and in soft drinks. Nitric acid and sulfuric acid, manufacture of chemical fertilizers, paints, dyes, etc. Dyes means coloring substances. Sulfuric acid, automobile battery. Tannic acid, production of ink and leather. Next is uses of alkali. We are using alkalis for many purposes. First one is manufacturing of soap, manufacture of detergents and ceramic materials, industrial purposes, purification of water. And as you know, as we have said, we can make soap by using alkalis. Let's see how to make soap by using alkalis. Step by step process. Materials required: sodium hydroxide, coconut oil, water, and sodium silicate, stone powder. Dissolve caustic soda in water taken in steel vessel. Heat is liberated when caustic soda dissolves in water. It is an exothermic process. Heat will come out when we are mixing caustic soda in water. It takes 3 to 4 hours for the solution to get cooled. When the solution cools, pour it slowly into coconut oil taken in a plastic or steel vessel and stir it. Add stone powder and sodium silicate. These things will be available in shops. You can get soap making kit from shops. This is to increase the hardness and quality of the soap. Stir well till the mixture solidifies. Perfumes and dyes may be added for fragrance and attractive color. You can add color and smell. Pour the above mixture into molds. In 3 or 4 days, the mixture becomes soap. The soap taken from molds should be used only after 2 weeks. So like that, we can make soap in our own home. So that's all about our topic, acids and alkalis. Watch the videos repeatedly. If you have any doubt, you can clarify in our live session. Thank you. Have a nice day.